Welcome to another video here from Chapter 6 dealing with the normal distribution. We're going to be looking at using the table that you'll find in your textbook. It's Table E, and it is located on page 788 in your textbook. It's the standard normal distribution. Notice here on page 788, you're looking at negative z-scores. If you look at page 789, you'll be looking at positive z-scores. So in using the table, first of all, you will have to remember that a z-score, x minus mu over sigma. So you'll be using those to go from one normal distribution to the standard normal. Now, to use it, let's look at probabilities in the standard normal distribution. Probability that z is less than negative 1.53. So it's a negative value, so we look at the negative z-scores, and we have to go down till we find a 1.5, negative 1.5, so the ones column and the tens column. And underneath the 3. So as you look at that, you'll notice that right there is 0.630. So in answering that one, that would equal 0.0630, and it's always 4 place values. Always. And when you're looking at the normal distribution, if we're looking at the probability that z is less than or equal to negative 1.53, that's also 0.0630, and that's because the normal distribution is continuous, whereas the binomial was discrete. Probability that x was less than 4 was not the same as probability that x was less than or equal to 4. That's one of the differences between the continuous and the discrete. Another item, the probability that z is greater than negative 1.53 equals 1 minus the probability that z is less than or equal to negative 1.53. That was a technique used previously. It's the complement rule. That works in any distribution, whether it's continuous, no special items are needed. It's also equal to the probability that z is less than positive 1.53. And that's because of the symmetry. Because of the symmetry. That does not work for a binomial distribution, but it does work for normal. If you looked on the positive scores there, 5 3s, you'll notice the 9370 as the positive z probability. .9370. Get it directly using the positive score, the symmetry, or you could use the 1 minus the 0.0630. If you look at the probability that z equals negative 1.53, that's 0. And that's also because it's continuous. There is no exact value, if you will. So you will not have a question that says, what's the probability that z equals? If you're dealing with just a regular normal distribution, that's where this table is going to be applied. If you have a mean of 50 and a standard deviation of 2, these have to be given to you in some form, either in the word problem or just stated as it is in this case. We will be dealing mostly with word problems. If we are looking at the probability that x is less than 53, first make a sketch. We know it's centered at 50. Right over here somewhere is 53. So we know we're looking for that part of the probability. We can shade that. Our z-score, x minus mu over sigma, 53 minus 50 over 2 is 1.50. Going to our positive z table, (1.5) and the 0. That is a 9332. Excuse me, 9332. So that would you be using the distribution in the normal distribution, the standard normal, to find a probability in the normal.